So here we have a screenshot of a problem that cut off the number. So this is problem number 8. Anyway, we have to determine the second derivative of this function here. So the function is q of v is equal to 2 over 6 plus 2v minus v squared raised to the fourth power. Now just looking at this problem, it seems like it's going to take a while. Or at least space. So let me try to make some space here. So we have this. I'm just gonna write it down here. Okay, so anyway, we want to first find the first derivative, and then let's go for the second derivative. So the first derivative, this is a function that we can differentiate by doing two things. So we can either take this denominator, we can move it up, make this negative. So this is just going to be times 6 plus 2v minus v squared raised to the negative fourth power. That's also completely okay. And actually, this would be an easier way to do it. But another way to do it, and this is not the derivative. This is still the same function. Sorry. Okay. And then another way to do it would be to rewrite it by, or not rewrite it, but use the quotient rule. So that's one way. I actually prefer this way, so I'm just going to use it this way, and it's a much easier way. Whenever you have like a constant up here, you can try to do it this way because it's much easier. Or if you have a variable, that also works, but you would have to do the product rule. Anyway, let's do it this. So this is just going to be equal to q prime of v is equal to, so 2 times negative 4, so 2 times negative 4 is negative 8 times 6 plus 2v minus v squared raised to negative 4 minus 1. That's negative 5. And then you multiply by the derivative of the inside. Okay, derivative of the inside is just going to be equal to 2 minus 2v. I don't like it like the way it's written, but you could have just rewrote it like this, right? And then just did negative 2v plus 2. Same thing as that. Same thing. Okay. Same thing. All right. So this is technically your first derivative. And we can combine some things, but let's leave it like this for now. Let's just work with it like this. So, actually, I'm probably gonna combine this. So let's combine this and this. Okay. So that's just gonna be what? Negative 16 plus 16v times divided by 6 plus 2v minus v squared to the fifth power, but times 6 plus 2v minus v squared raised to the negative fifth power, because we're going to write it like this anyway. Now we have our beloved product rule. So double prime is equal to the derivative of the first, which is just going to be 16, times the second, which is 6 plus 2v minus v squared raised to the negative fifth power. And then what do we do here? So then we add this function. Okay, negative 16 plus 16v times the derivative of this function. That's just going to be, we have a negative 5. We can bring that down there. And then 6 plus 2v minus v squared raised to the negative sixth power. This is technically a good answer to leave it like, except we forgot one step. Multiplying by the derivative of the inside. We forgot that, right? We have to do that. We have to multiply by the derivative of the inside, because this is the product rule, and this is the derivative of this function, which is a chain rule. So this has to have the derivative of the inside, which is just going to be equal to, same thing as before, 2 minus 2v. And I'm kind of running out of space here, but you'll see the answer much nicer when I rewrite it. So let's rewrite it. Q double prime of v. So this is kind of a messy problem, but let's rewrite it. So this is going to be 6 plus 2v minus v squared raised to the fifth power And then we can do is we can actually we can do minus, right? Minus, and then we can have a 5 and then multiply by 2 minus 2v times negative, so actually I'll just do 16v minus 16, and then all of this divided by 6 plus 2b minus v squared raised to the 6th power. That's it. We can combine the denominator here, but I don't want to. I would prefer to leave it like this, so this is good. Okay, that's it. This is your answer. It's kind of messy, but this is your answer. And this problem would be a little bit more of a time-consuming / challenging problem. Not so challenging, but time-consuming, and you have to be careful to not make mistakes. Anyway, I hope you found this video helpful.